Good day my friends, and welcome back to the X-Explorer for another video. I'm Yankee Oscar 6 Delta X-Ray Echo, and today I hope we have another exciting video for those that are into VLF, especially for those that are excited about every time the SAQ transmitter in grimeton is actually transmitting something, and we have these special occasions. Now, unfortunately, I had a fail with this last transmission from a couple of days ago, and we'll talk about that towards the end of the video. But I did successfully receive the both transmissions. I believe they were in July, if I remember well. I can't remember exactly. And I used these two Spherix receivers. It was just an experiment. This one has a built-in audio amplifier. This one is simple. It has no batteries, no built-in audio amplifier. This one gets its own power to work. The JFET that I have inside used as a preamp from the audio input to whatever sound recorder is connected. And I connected both of them to my 20 meters band vertical antenna, and I used that one to receive the signals. Just because I'm trying to use something that I already have, so I don't have to build extra things. I tried doing something similar this time, and I put together on a breadboard quick circuit, an up converter from VLF to 10 megahertz. Unfortunately, I did a mistake and I failed. I actually connected the converter to my end-fed half-wave antenna, not to my vertical. And these have the same issue, by the way, not just the converter. If I connect them to my end-fed half-wave antenna, I believe because of the impedance transformer something, or the capacitor that I have installed in the transformer, something it's not right, because I don't receive anything even with this. So I have to be on the vertical, and unfortunately I forgot to change the antenna. I was actually on the end-fed half-wave, and I was convinced that I already swapped the antenna, but I didn't, so I missed the transmission. But anyway, I built the circuit successfully, the VLF converter. I already designed the PCB board for this one as well, just in case you like it and you'd like to try it as well. So feel free to order it and build it for yourself. You'll have a link in the video description to the PCB board. And talking about PCB boards, of course, I cannot continue without saying thank you to my friends at PCBWay for always sponsoring and supporting the X-Explorer channel. They have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more available for you. Do not forget about the module store. And by the way, talking about the module store, I have to go and order some solder from there as well. So feel free to find something that you like and order everything together with your PCB board, so you receive everything in one package. And when it comes to my own project, you'll have a link in the video description that you can find all the projects that I presented so far. And right now I'm in updating process. I'm updating all the PCB board designs that I made so far, and I can start fresh with some new designs very soon. As I'm always saying, PCB way is the way. So back in 2023, my friend Andre, Yankee Oscar 6 Tango Juliet Juliet, wrote some really nice articles on VLF in the first number of the radio magazine, which by the way you can find right now on the Railways website in the English version. It's translated in English. It's downloadable PDF files. So he wrote an article about a nice receiver based on for VLF, based on a schematic by Delta Juliet 1 Whiskey Foxtrot, and I want to build this one as well. I think I have most of the components. I'll have to find and figure out the entire list, and then I'll build this one as well. But because I'm trying to take it slow, back then I really wanted to build this VLF up converter. And this was originally published, I believe, in the Elector magazine back in June 1988. Ah, yeah, it's written over here. And I wanted to build this one right now, but I didn't have the inductors on the to build the filter on the input, and I figured out that it's a little bit too complicated, so I decided to try to simplify it as much as possible, because I'm not exactly looking for performance, I'm just trying to experiment a little bit, but it turned out really good and a lot simpler than this one. So let me show you what I have right now. So I ended up with this tiny circuit. Now excuse the mess created by the connectors, but these are here just temporarily to do a couple of tests. So I built this one Manhattan style, and technically I honestly wanted to put a shield between the output filter and the oscillator part, and another shield between the oscillator and the low pass filter on the input. Unfortunately, I ran out of not just the solder, but I also ran out of copper boards, and I had to build everything on this tiny little piece that I had left. So because I kind of squeezed everything together over here, I also had a little issue. I could still hear a little bit of the oscillator into the receiver constantly. Doesn't matter on which frequency I was, but I managed to solve that issue by placing just one simple capacitor over here on the output, and yeah, but I had that issue which I couldn't figure it out and why it did it. When I did the test version on the breadboard, but doing it on the breadboard, it was a bad idea. Things were constantly not making contact, and it didn't work properly, so I decided to build it on this way, Manhattan style, and it works fantastic, and I'm really happy with the way it performs. So anyway, let's not waste any time. I'll put the schematic on the screen for you to have a look. It's very simple. I just basically I took little bits and pieces from schematics that I found online, and I built the filter, just the up converter the way I wanted. The low pass filter, again, on the input is designed from basically to work from 0 to 77 kilohertz, and after that it will start cutting the frequencies, just because I didn't want to listen to anything higher than 77 kilohertz. So yeah, if you're interested in that, just stick around towards the end of the video. I'll explain a little bit about how we can design a filter. Also the output transformer, so on the output, because I'm using both outputs, each of the outputs has of the SAQ612 or the NE612, they have 1.5 kilo ohms, and because I used both of them, then that the total is 3 kilo ohms. So I had to somehow create a transformer to adapt the impedance from 3 kilo ohms down to 50 ohms, the output that goes to our transceiver, in my case set on the 30 meters band on 10 megahertz. On the input, actually the filter is calculated, the input of the NE602 has 1.5 kilo ohms impedance. So what I did, when I calculated the filter, I did not use 50 ohms as input and output. I actually used 1.5 kilo ohms, but the filter turned out really good and it works fantastic. I don't seem to have any problems and interferences from the broadcast band. I received the stations pretty strong, and I'm actually using it with my 50 ohms, the 20 meters vertical antenna. But in the future I will actually use it, this one in particular, it's made to use it together with mini whip antenna, which I will install later on once I finish moving in my new location. But yeah, it works fantastic, and so far I like it. So anyway, let's not waste any time. Let me show you how it works, and after that we'll talk a little bit more about the filter and whatever I did to the little circuit. And yeah, this is it. I'll have to put it in a metal enclosure, but I don't have any closure right now, so yeah, we have to wait. For now I'm experimenting with it the way it is. to power this prototype, the up converter actually, because I didn't put any voltage regulator or any Zener diode on the board itself, but that was the reason, was that I want to use it with this voltage regulator. This one I can power it with anything between 6 up to 15 volts, and it will constantly power my converter board to 6 volts, or probably I will set it up to 5.5 volts. I believe the SA612 chip works with anything between 5 to 9 volts, I believe. So yeah, I'm going to use it with 5.5 volts or 6 volts, probably 5.5, and power it with this module, which by the way you can also find in the module store from PCBWay. But the actual board that you will order, it will be it will use a 6.8 Zener diode, and it has a resistor on the input, and another 1N4148 diode protection for like reverse voltage protection, and that one you can power it with anything between 9 to 15 volts, unless you want to skip those and you will use something similar like I do. But yeah, just to give you some ideas, I'll put both of them in the same enclosure. So here you have it right now, all powered up, and let's move on the transceiver really quick and listen to a couple of VLF signals. So again, one more time, this will convert for the VLF frequencies up to the 10 megahertz, basically the 30 meters amateur radio band, except that we're going to start exactly from 10 megahertz. So you can listen to VLF signals using this converter, using any receiver that can receive the 10 megahertz portion of the band. Okay, so we are of course converted to 10 megahertz, but we're actually listening to 18.1 kilohertz. On this frequency, I believe there's some Russian military VLF network that it will start transmitting anytime soon. But meanwhile, we can play around a little bit and go up. To on 20T.4 we have the German Navy. And it works pretty nice. I'll put towards the end of the video, I'll put a separate video where you can listen closer to the receiver. Right now the sound is picked up by my lavalier microphone. Let's go down. Do we have a transmission? Yeah. So the transmission on 18.1 kilohertz started, and obviously it will take a while, then it stops. But yeah, it works really fun. I like it. It's really quiet. I don't have any broadcast band interferences. It seems to to have a good output with like the gain with the transformer that I made, so it seems to work well. And I'm also really happy again about the low pass filter on the input. So when it comes to the SAQ transmission, which will be sometime during Christmas time, that one should be on 17.2 kilohertz. So yeah, I hope next time I get to hear it, because this time I wasn't so lucky. So anyway, but yeah, anyway, I'll leave you more of this towards the end of the video. We'll play around a little bit if you have patience and if you're curious. Let's talk really quick about the filter. So when it comes to VLF stations, if you're interested in finding out what exactly you're listening to, there's this mwlist.org vlf.php something. I'll put a link in the video description to the website, but you can find over here all the stations and on what frequency they're transmitting, and I believe they are up to, let's see, up to 148 kilohertz, so basically 150. But again, as I was saying, in my case with the filter that I built, I'm up to 77 kilohertz, and after that the quality, the level basically of the transmissions will be lower and lower as the filter will cut them down. So let's have a closer look to the filter that I built. And I believe I saved here a version, yes. So now the one that I'm using right now, can you hear it? This is the transmission on 18.1 kilohertz. So the filter that I'm using, it has this 4.7 millihenry inductors, just because these are the ones that I had available. I'm using a 2.2 nanofarads capacitor here in the middle, and in each end I'm using 1 nanofarad capacitors. If right now, let's go to analysis, I'm going to put from 5 kilohertz, let's put 1 kilohertz up to 30 megahertz. I'm not very good with this software, but I think I figured it out well enough to help me design the filters. So if you take a look over here, we are on 75, 79, 80. Let's say it might be still usable, somewhere around 90 something, 80 kilohertz. After that it goes down. On 88 kilohertz it already has minus 2.4 dB of attenuation, and by the time we get to 320 kilohertz is minus 60 dB of attenuation. So the filter seems to work really nice. But if you want to go a little bit higher, what I would recommend, let's see if we can modify this. Let's put 470 microhenry with 470 microhenry. Let's see what this one does. All right, it goes up to 302 kilohertz. So I might have to lower, let's lower this one to, let's say, I don't know, 470 picofarads, and this one to 47 picofarads. We're just gonna play around a little bit. Yeah, not bad. It's a little bit too much, but yeah, so this one should work somewhere up to 200 kilohertz, and after that it will start cutting down, and by the time you get to 3.5 megahertz you should be somewhere up down to minus 60 dB. If you think it's too much, maybe let's see if we can increase this one to 820 picofarads. I'm trying to use standard values. About the same, so it's not a big difference, but you get the idea. Basically you just play around with the values a little bit. So again, for this particular one, if you want to receive something higher than 77 kilohertz, and if you want to go up to 150 kilohertz, for example, you could probably use, let's see, with 680. Yeah, this one is much better. So again, it's up to you which filter you prefer. I set it up this way simply because I wanted to listen to a bit more signals, not just the SAQ. but I wasn't so interested in frequencies higher than 77 kilohertz because I think it's enough for me to receive in VLF on that one, and especially that my transceiver in particular it doesn't go very high because it's the 30 meters amateur radio band, and I believe mine stops at 150. I'm not sure, let me see. 83, yeah, at 150 it stops, so 150 kilohertz. So I could build the filters that way. Maybe I'm going to put 2.2 microhenry inductors instead. I don't know, just so I can go a little bit higher, but honestly I'm not that interested. I'm just going to leave it as it is. The idea for me is that you have many options to receive the SAQ. So again, you can use any of these two Spherix receivers together with the SAQ RX software from the Alexander Association, or you can use the up converter with a transceiver that's capable of receiving the 30 meters band, or any simple receiver. And the test that I'm going to do this couple of days, once I put it in an enclosure, I'm going to go outside and use it with this telescopic antenna. So this is the only one that I'm going to connect to the converter, and use this one as an antenna, and then the converter will be connected to this tiny receiver that I received from my friend Vlad, Yankee Oscar 5 Bravo Delta Lima. This one, where's the volume? This one does not have CW setting. Let me see, mode. Maybe I have to do an update to the firmware, but no, it doesn't have CW, but it has upper sideband, so I can play around and tune it in such way that I can actually hear the signals, even the CW signals, and I can play around with the filter and go as low as 500 Hertz. So it's good. I want to test receiving VLF signals on this one together with the up converter. So these are, probably you have three methods right now to receive the SAQ and other VLF signals in case of our up converter. For the SAQ in particular, I will have another method that probably I'm going to post a video about in the future, which requires just a small preamp that you connect it to your laptop. And for an antenna, let's say you're portable or you're in some limited spaces where you cannot have antennas, you will only have a small ferrite antenna with an inductor on it, and we'll use that one. And you can tune it somewhere between, let's say, 15 up to 22 kilohertz, so somewhere in that range. And I think that one will be great for the SAQ transmission as well. And obviously, hopefully by Christmas time I get to finish the VLF receiver, because I have most of the components from Andre, Yankee Oscar 5 Tango Juliet Juliet, for that receiver that I was talking about, that he wrote an article about in the radio magazine, and I'll try to build that one. And hopefully for the SAQ transmission during Christmas times, I get to record the whole thing using the up converter and the vertical antenna. Or maybe meanwhile I might build some other antenna, and also to go outside and listen live on the receiver, because for me nothing beats the feeling of receiving everything outside. I'm not sure why. So I decided to build the impedance transformer on a T50-6. Considering on the output we actually have a 10 megahertz signal, so T50-6 is the best fit, I believe. And again, now this version that I'm showing you right now, it's on a T68-6, just because I wanted something bigger, so it's going to be easier for you to understand. But I used 32 turns as a primary. So let's imagine that these are the 32 turns of the primary that we use. So this one, the primary, will go onto the output to the pins 4 and 5 of the IC of the SA612. So now we have to wind the secondary, and you will see on the PCB board the way that it will be. You will have 4 points to connect the transformer. The secondary is going to be in one side and the primary is going to be in one side. So what I did so far, I started from here, right? So this is the beginning, and I went all the way around, and let's say these are 32 turns. I'm not sure how much they are here because I just wound some turns just to show you as an example. So what I'm going to do with the secondary right now, I'm going to start from here, and to make it easier for you, you can actually use different colors wires or different thicknesses. That's what I use. I use a different thickness. So I pass the wire once through the toroid. This is already one turn, right? And this is actually valid, of course, for the primary as well. So we have one turn, we have 2 turns, and you can squeeze these turns between the turns of the primary. 3 turns, and obviously you can make it way neater than I do. I'm trying to look both at what I'm doing in the camera as well. So this is the secondary, and we cut the extra wire, we scratch the insulation from the wire, and then you solder it to the PCB board. And it's very simple to connect it. Again, these two are the primary, the 32 turns that go to pins 4 and 5 of the IC, and this is the output. This is what goes to the receiver side, to the output of your VLF converter. And if you look down, you have all 4 wires close to each other, because once you solder it, it will stay like this on top of the PCB, right? Standing up. So I hope it helps. But it's very simple to wind, and to be honest, for me this was the easiest method. I tried 1, 2, 3, 4, 5 different output styles on my breadboard, and this one with the transformer was the easiest one, and I had the best results, both in the strength of the signal on the output, and also it was easy to build, basically, without using too many components, just one inductor. So I hope it helps. So right now I'm using the external microphone from the desk to record the audio of the transceiver directly, and this is the way the up converter sounds once we set everything on 10 megahertz, and I'm going to go with the filter down to 50 hertz. So as you can tell, it's very well calibrated on 10 megahertz. So from now on, I can widen the filter to 500 hertz, and let's start playing around and listen to some sounds. Let's see, around 12 kilohertz. I think there's some navigation system for submarines. Yeah. So you have a lot of interesting things to listen to. Let's go a little further. Again, you can take a look at that list. I'll put the link in the video description. Not sure what is it on 15 kilohertz. I received some signaling here as well. I'll have to take a look at that list as well. Then we go again higher, again to 18.1 kilohertz. Then there's something else around 19.5, 19.6. And by the way, again, think about it that the input of my VLF converter is designed for high impedance antenna. So the input has 1.5 kilo ohms impedance, and I'm actually I connected my 50 ohms vertical 20 meters band vertical antenna into this high input, and it still works pretty fine. So I wonder if I'm going to design some sort of loop antenna with some impedance transformer, if I get better results, because I should have stronger signals this way. So yeah, we have a lot of stations over here. Anyway, let me show you really quick how I tune this whole thing on 10 megahertz once I finish building the up converter, and you'll have to do that as well. So lucky me, I have this filter that allows me to go to 50 hertz bandwidth. But let's say you see, I can move this one a little bit to be able to center it on exactly 10 kilohertz, 10 megahertz, sorry. So what I'm going to do, I'm just going to rotate the variable capacitor on the up converter until I get this oscillator sound on 10 megahertz straight, and after that I'm ready to go. And I can still hear a little bit of the oscillator into the receiver, you see. But this is probably for two reasons. One is that I did not separate the stages, and I didn't put any shielding between the stages, or other reason is that it's not in a metallic enclosure yet, and it's easy to be picked up by the receiver. And the third would be that maybe just this Manhattan style method is not very good. You see, so I still have to adjust it a little bit. So now I'm receiving the 18.10 kilohertz signal. Exactly on 18.10. So yeah, that's it. Thank you so much for watching, and I'll see you in the next video. Until then, 73 from Yankee Oscar 6 Delta X-Ray Echo.